Well, Bhumit, we are going to work with this PMF and I have shown a plot of this. And you can see that here the PMFs are going up for some time. So each bar, the height of this bar is equal to this for the given value of x. Initially they are going up and eventually they are coming down, and here two bars happen to have exactly the same height, and we have to show this structure. So for this, what I will do is I will take ratio of two consecutive such thing for some value of x and x plus 1. So I have to check when this is greater than 1, equal to 1 and less than 1. I will do all these things in parallel. When it is greater than 1, this means the next is higher than the current value, so it is going up. When it is equal to 1, I have two things which are equal. When it is less than 1, I am coming down. So I will have to check when I have these equalities and inequalities. So let's first simplify this expression. When I take ratio of the two choose terms, I will be left with this. Then I will cancel the p's. And finally I will cancel the 1 minus p's. So I am left with this, which I have to simplify. Observe that this is positive, so I can safely bring it here without disrupting the inequalities. So now I will have to just open the brackets and see what cancellations I get. And I can see that xp and xp cancels off. My aim is to take all the x's to one side and all the other things to the other. So I have only x here, so I want to keep this x and take this on the other side. So I have achieved my first part. I will increase means this inequality when x is less than something. And that is indeed true, up to a level I increase. Similarly, I will decrease, that means this inequality when x is greater than something. So after a stage I will decrease. Now the focus will be on the equality case. So let's focus on the equality case. When do I have equality? Remember that this is an integer, this 1 is an integer, and if I write this in a combined way, I will have n plus 1 p minus 1. So if these two things are integers, for equality to hold, I must have n plus 1 times p to be an integer. Only then I have any hope of having equality. If I do not have this an integer, then this equality case is just impossible. So when I do have equality, then for this value of x, this and the next value will be the same. So now you see why I need n plus 1 times p to be an integer. If it is not an integer, in that case your plot will look like this. So you see, you go up and then immediately start coming down. You never have two things equal. So if n plus 1 times p is not an integer, it will look like this. And if it is an integer, then it will look like this, where two values will be the same. So now you understand why we need that condition.